Hey, hello friends. Microsoft just released their latest open source model called Orca 2, which is the next generation of Orca model. In this video, I will discuss why Orca is going to revolutionize AI, and also I will show you how to use this latest model on your Google Colab. In the last few weeks, so much happening in the AI field that it's not getting the attention it deserves. I'm here to break down everything you need to know. So without further ado, let's get started. The first question in your mind is probably why Orca is so special compared to other LLM models. Let me tell you that Orca trained on synthetic data, which is produced by other large language models like GPT-4. Synthetic data created by AI itself, a different approach from traditional methods that are more costly and less efficient. Orca 2, built on previous Orca 1 paper, focuses on small model how to reason. Researchers found that the quality of the data is more important than the quantity of data. And synthetic data just as good as human generated data. It's possible to teach smaller model how to reason, and by using large language model to generate prompts and answers. This is important because it means we can create smaller model which is more efficient and still capable of reasoning. Now let's take a look how you can use Orca 2 model on your Google Colab. In this tutorial, we will use oobabooga text generation WebUi, a powerful yet simple to use WebUi. Search for oobabooga WebUi on Google, then go to GitHub repo and copy the repository link. Open your Google Colab notebook, create a new notebook, change the runtime to GPU. Colab provides free Tesla T4 GPU and connect to it. In the first cell, clone the oobabooga text generation OVI, then change the directory to the text generation OVI folder. After that, run start linux.sh. This process will take some time, and during installation, choose GPU option A and CUDA N for the latest CUDA version. Now we can see it has successfully run and given us a local URL. In Colab, we can't use a local URL, so we need to in Colab we can't use a local URL, so we need a gradle link. Stop this cell and run update linux.sh as recommended in the oobabooga documentation. After the update, install all necessary packages. After a while, when all packages are downloaded, we are almost done. Now just download the model you want to run. Open Hugging Face website, go to the model tab and select desired model. I'm going to use quantized model. Copy the model URL and paste it in the oobabooga model folder. The download process will take 1 to 3 minutes. After downloading the model, run the Python server file. Don't forget to use the share flag to enable the Gradle link, otherwise you will only get a local URL. Click on the Gradle link and it's up and running. Go to the model tab and select Orca 2, then load the model. You can play with all parameters, but for now I will leave them as they are. Let's ask some questions. Give me all prime number from 1 to 100. Let's see. Orca gives us answers and they seem correct. Oh no, I think 48 is not a prime number. Now let's ask to generate Python code. The model is generating an answer, but it's very slow. However, let's see. When I edit this video, I will fast forward this part. We can see Orca writing a function for checking prime numbers. Now it's defining function to print all prime numbers. The code looks good. Let's copy and paste it into my PyCharm. Let me correct the indentation. It looks perfect. Let's run it and wow, it's worked so well. I think it's not good as GPT-4, but one thing to remember that we are using 7B model, which is the smallest. If we had used 13B version, the result might be better. Okay, those are just my thought. What do you think about this model? Let me know in the comment section. Although it's not the best model out there, The way it's trend definitely show what's coming. I hope you enjoyed this video. If you did, please don't forget to subscribe. Please help me reach my first 1000 subscriber. Thank you and see you in the next video.